Alright, so yesterday we spent our class time, we talked about the different types of minerals. You guys got a chance to see what they all, what it's all about. Some of you guys think you're too excited, which is fine. And then today we're going to look at is more how we start classifying these. How does, you guys, are talking to me and I pick that up like, oh yeah, well this is an example of this. And you might ask, well, how do you know that? How can you tell just by looking at it what it is? Well, that's what this lesson is all about. It's teaching you how to look at the different characteristics of these minerals to help you identify what those minerals are. Now, on Thursday, you guys will have a quiz in which you'll have to identify 10 different minerals. So it's really what you're going to use today. The spreadsheet I just handed out to you guys, you can use that on your quiz. So here we go. The first thing we're talking about today is color. Now the color of a mineral is, and again, here's the big idea, and we're going to keep saying this one a lot today. It's caused by trace elements. Okay, now what does that mean, trace elements? What are trace elements? What does that mean? Okay, it's similar to if you've had like a drug screening, they might say, well, we found trace elements or trace amounts of this. What does that mean, trace amounts?
Things that have existed? Yeah,
they're very small amounts, right? And we're just barely able to detect them. And so we look at the color of that crystal or that mineral is basically because of the small amounts of a new element that has been thrown in the mix. And a perfect example of that is quartz. And all three of these crystals that you're looking at right here, all three of these are quartz. And quartz comes in a whole bunch of different colors. And it can also have rose quartz. And so it's just a lot of different colors that can come in there. So when we look at this, basically there are some minerals that have a unique color. Perfect example of that is the azurite and malachite that we saw yesterday. Remember, what color was malachite? No.
Green.
Green. The malachite was green. And azurite, just like Spanish for blue, so azul. Okay. So azurite is a blue color. And those are pretty consistent. You're not going to see azurite in a different color. Malachite's always green, azurite's always blue. And that's a very rare outcome. A very rare outcome. A lot of times what happens, most of our minerals are able to change color. And quartz is a perfect example of that. Calcite is another example. The blue piece I have right here, this is blue calcite. We've got green calcite. Sometimes like the calcite that's in your box kind of looks dirty. Right, that's this piece right here. So this is calcite. It's kind of brown with a little bit of white. So calcite, again, can change its color all the time. The same thing with fluorite. So these colors, where are they coming from? Well, when we look at the citrine, remember that's still quartz. Where does that rust color come from? Iron. So we got small amounts of iron in that makeup. Now quartz is pretty much pure silicate. It's SiO4 with a little bit of iron thrown in the mix. Smoky quartz, and it kind of makes sense why they call it. If you've ever seen a piece of smoky quartz, it looks clear at the bottom, but then the farther you go up that crystal, the darker and darker it gets, and it kind of has this smoky look to it. And that's from trapped CO2. So you actually get these gas bubbles that are trapped inside the crystal, and it distorts the light, you kind of get to this cloudy look. So again, that's those trace elements that come into play. So now what I want you guys to do, you're going to go through your box of minerals, your box of rocks, and I want you guys to take just a couple minutes and you're going to fill out the colors for each one of the minerals in your box. Luster. Basically, all we're talking about luster, it's how the light's reflecting off the surface. So So it's how well the light reflects from the surface. Perfect example for this is galena. Galena is basically lead sulfide, PBS. PB for lead, S for sulfide, and it's very dense, very heavy. So everyone passes it around, but if you notice, it reflects just like your crystal minerals because it is metallic. And so that's what we mean by luster. Now, an example of a non-metallic luster, and there are tons of those, you know, we get dull, pearly, waxy, silky. It's just, so how does it look to you? How, you know, in what way does it look to you when it reflects the light? Is it dull? Does it kind of have a waxy look to it? Is it pearly? And so that's more for you guys. You don't have to worry about getting this one right. It's more for you. How does it look to you? So take a few minutes and fill out the luster for the minerals in your box. So let's make sure we have this. So we've already talked about luster. Now we're talking about streaks. Nice. Oh, we'll get to that later. It's a fun day. It's my favorite day of Chris life. Alright guys, so here we go. We're looking at streak. There's a streak of a mineral. And that's the whole point of the porcelain plate. That little white thing that's in your box. That's called a porcelain plate. And it's there for one reason only, is to do the streak test. Now, the streak of a mineral is basically the color that's left behind when you scratch it on the streak plate, on your little porcelain plate. Now, what is this? Which is called pyrite. What color is it? Gold. Pyrite's gold. Yes. Take that same gold mineral. What color do you think it will have?
Black.
Purple.
Purple, gold. Purple, brown.
I said purple. If I'm right, you guys will find out.
What color did I get? Black. So does the streak always match the color of the rock?
No.
No. Okay, now what the streak really is.
Yell at it.
Yell at it. Beat it up.
You're old and black.
It's like raising monkeys out there. Alright, so. So basically the one thing again is the streak is basically when we take up that rock or that mineral and we grind it into a powdered form, and that's literally what's happening. The residue that's on the porcelain plate is the ground up or powdered form of that mineral. And whatever color that powdered form is, that's basically called a streak. And most times it's not going to match the mineral's exterior color. So we all often said, again, for example, we have pyrite, which is gold, and then it comes out to be black. But the neat thing about the streak is that the color doesn't change. If I grab your pyrite out of each one of your boxes and we do a streak test, all the pyrites will be black. Now let me ask you this. If all my pyrites are black, does that mean if I have a black streak that my sample must be pyrite? No, okay. So it's very important to understand what the connections are here. So let's say I pick up an unknown mineral, and I look at just the color alone. Can I guarantee myself what that mineral is with just the color alone? No. Can I do it by just the luster alone? Obviously, can I do it with just the streak alone? No. Alright, so what we're doing today is we're showing you guys the multiple tests that you need to do to verify the identity of an unknown mineral. So now what I want you guys to do is take a few minutes and find the streak of the minerals. By the way, not every mineral is going to have a streak, because the streak It's only if the mineral is softer than the porcelain.
So do we put it in our street?
No street.